Okay, this is the second example of absolute values and inequalities. And this one is going to take a look at the absolute value of something being greater than a number instead of less than. And so those solutions are going to be different looking, and the solution graph will also look different, or number line. And so we're looking at 2x plus 8 being greater than or equal to 4. What does that mean? It's important to understand what it means. It means that 2x plus 8 is more than 4 away from 0. It's either 4 or more than 4 away from 0. And so we graph that so we can see what's happening on here. And so here's our graph. And we're going to establish our boundaries of 4 and negative 4 because those are exactly 4 away from 0. And then we got to fill those in because we are having a greater than or equal to situation. So we got to fill in the circles. And as we look at this then, we realize that 2x plus 8 has to be greater than 4 away from 0. So we take a look at negative 4. This is 4 away from 0. So we're going to go further away from 0. And so there it is. And so we can say then that 2x plus 8 here is going to be all the values negative 4 and less, because those are all further away from 0. Now if we look at this other boundary, then that's 4 away from 0. So in order to get further away from 0, we got to go to the right side. And so there we go. So 2x plus 8 is in those two situations. Now this is an OR type situation because negative 5 makes this inequality true, but it doesn't make this true. So as long as one or the other is true, then this thing works. So now we're going to write our inequalities from this. And so we can say then, as we compare 2x plus 8 and the boundary, so how does 2x plus 8 relate to this boundary? Well, 2x plus 8 is less than or equal to this boundary. So there's one inequality, is 2x plus 8 is less than or equal to negative 4. Over here, 2x plus 8, how does it relate to this boundary? Well, 2x plus 8, the boundary is less than or equal to 2x plus 8. In other words, 2x plus 8 is greater than 4 because it's on the right side of 4. And so we write our two equations. And I write the 2x plus 8 on the left side because we want the x to be on the left side. So here's our two inequalities that we formed from the graph, using the graph as a visual. And so now we're going to solve each one independently of the other. And so the first one, we want to get x by itself on the left. And so we add 8 to both sides. So we are now at 2x is less than or equal to negative 12. So we want to get rid of the 2. So we divide both sides by 2. So x is less than or equal to 6. Now, we're going to now go over to the other side and solve for x on this side. And so we add 8 or subtract 8 from both sides. We end up with 2x is greater than or equal to negative 4. Divide both sides by 2. And now we have x is greater than or equal to negative 2. Now this is an OR situation. When you have a greater than, you have an OR. It's also called a union. X is less than or equal to negative 6, or x can be greater than or equal to negative 2. So we graphically represent that. We have our two boundaries. It's how x relates to negative 6. How does x relate to negative 2? It's less than negative 6, so it's going to go to the left. And it is greater than or equal to negative 2, so it goes to the right. And so those are the values of x. Now we want to check our solution. And so we're going to go over here. Here's the original equation and our inequality, and then we have our answer. So we're going to, as we look at our graphic representation here, we want to pick a number that's in the green. And something in the green should make the original inequality true. So we're going to substitute -7 in for x, and we get -14 is plus 8 is greater than or equal to 4. -14 plus 8 is -6. The absolute value of -6 is positive 6. So is 6 greater than or equal to 4? And yes, it is, and so it makes that inequality true, which is exactly what we want. We're going to pick another one. We're going to pick a -1 over here because this also can make it true, but it's in a different section of the graph. And so we're going to test that guy out. And so we get where we have -2 plus 6 is, or plus 8 is equal to 6. Absolute value of 6 is 6. Is 6 greater than or equal to 4? And yes, it is. So again, our solution is looking really good right now. We're going to test one more number, and we're going to pick a number here that's in the non-green area, and this should make the original inequality false. And so we're going to look at that. So -5 in for x, and we've got -10 plus 8, which is a -2. Absolute value of -2 is 2. Is 2 greater than or equal to 4? And no, it is not. Therefore, we've just proved that our answer must be correct. And that is how you check your answers. And then this is how my cats beg for food. As you can see, the water dish and the place where the food goes is right there, and they are in a close proximity to that area, and they just sit there and stare at me until I feed them. That's it.